Okay, so in 10 when we learned a lot of vocab, right? What a tangent, what a secant, what a point of tangency is, what a chord is, what a radius was, a diameter. And we talked about common internal tangents, common external tangents. So all that stuff was like part of the vocab. So where it says give the name that best describes the figure, remember sometimes there's two names for things. You want to make sure you're picking the best one. So if it says line CD, what is it describing? It's a secant. Yeah, so a diameter doesn't have endpoints. That's the trick to it. If this didn't have arrows, then it's a diameter, but because it's a line, it's actually the secant, which means it's passing through the circle, right? How about line AB? Tangent. Number 2 says tell how many common tangents the circles have. 1, right? If I drew one line through that point, it's going to hit both those circles at exactly 1 point. So this is just 1. 3 is AB tangent to circle C and explain. Is it?
Yes.
How do you know?
Because it intersects.
But it doesn't have to intersect at a right angle.
Yeah, I couldn't know because they're not congruent, right?
So 2 tangents would have to be, you are on the right track, but you have the wrong explanation.
No, A squared plus B squared.
There it is. In order for this to be tangent, this has to be a right angle, which means that 30 squared plus 16 squared would have to equal 34 squared. So this is 900, yes. What's 16 squared? 256. What's 34 squared? 156. So if I add that,
Yes.
what's true? They're equal, which means this is perpendicular. If it's perpendicular, tangent. Okay?
And you find the interior angles and also
Say that again.
if you find the interior angles, then you could say that it's the right angle.
Like if you actually found these angles, like using inverse trig.
Yeah, if we had
Yeah. But you're not gonna. So you want to rely upon your Pythagorean theorem. Okay. So it is tangent, and it's because AC is perpendicular to AB. You could say because A squared plus B squared equals C squared, it's a right triangle. So any of those things would make this true, but obviously the work's the backing of it, okay? If those are not equal, then it is not a right triangle, which means it's not tangent. If they are, then it is. And for this is now what? What theorem do we use? Okay, the one that looks like the ice cream cone, right? These are 2 tangent lines. If they are from the same spot, then they are congruent, which means 3x minus 1 would equal 2x plus 11. Subtract this. Add this. Good. Questions on any of the other overall stuff? 21 was kind of tricky, right? Because it gave you didn't know either of those radius. If you knew one, then you would know the other one. But so if I wanted to solve for r, it's still a right triangle. It's telling you that this is a right triangle. So I would say r squared plus 24 squared. Good. This whole thing would be r plus 16. So then I get r squared equals, plus, we just did this one, right? 576, thank you. Equals r plus 16 times r plus 16, which is r squared plus 32, r plus 256. And then the r squareds are going to cancel. Subtract 256. Oh, equals 32, r, and then divide by 32. So part of the challenge, especially on circles, and it's going to continue, is reading the diagram and knowing, like, does that 16 mean the whole thing, or does that 16 only mean part of it? If it's in the middle of a segment like that, it usually means just that segment. If it's 16, the whole thing, they'll usually do something like this. So just make sure you're reading them really careful, okay? And then know things like all the radii are going to be the same, so it makes sense that that would be r and r, that kind of stuff.
Wait, how would you do it if 16 was the whole thing, you only had r? Used to do.
And you had r, is that what you said? You would do r squared plus 24 squared equal, well, it would be wrong because 16 has to be bigger, but yeah. You just wouldn't need the r. Yeah.
So you would square the binomials for that one, because.
This one, yeah.
Okay.
Yeah. All right. So 10-2 is arc measures. So now we're talking about how to find the measures of arcs and circles. We did a little bit with segments. Now we're going to do arcs, so we eventually go back to segments. Okay, but so there's a little bit of vocab and then a little bit of application in here. Let's get the notes open. Come on. So the first thing is the definition of a central angle. A central angle is an angle whose vertex is the center of the circle. So the vertex of this angle has to be on the center. It's like a big piece of the pie. Okay, this angle itself is called a central angle. So in this diagram, angle ABC is a central angle. Arcs, okay, are formed by those angles. So an arc is a broken part of a circle. Think of an arc like the crust of a pie or a pizza, okay? Just that outer ring is the arc. There are 3 different types of arcs. Minor arcs, and if you think about minors, usually littler, right? A minor is less than half the circle. A semicircle is exactly half a circle. And a major arc is bigger than half the circle. So minor, semicircle, major. 3 different kinds. This one says, given DC is the diameter, arc AC is a minor arc. So if you look at arc AC, it's this ring here. Okay, that's a minor arc because it's less than half the circle. Arc DAC goes in that order. So I go from D to A to C. That's exactly half your circle, so that's a semicircle. And arc ADC goes A to D to C all the way back around that direction, and that's a major arc because it's more than half. So the order of the letters is important when you're going in the direction. It determines which direction you're using. You'll never see a minor arc with 3 letters. God bless you. Okay, if it's a semicircle, you're going to see 3 letters. Sometimes like a semicircle will have 3, but not necessarily, because if I called it DC or DA or CD, it's actually going to be the same measure. But then arc ADC is how I would know the direction to go in the order for that major arc. And you'll see it like that with the word, or you'll see this with an arc over it, and that means the same thing. So that's read as arc AC. All right, the measure of an arc is equal to the measure of its central angle. So if the angle has its vertex at the center, then that angle is the same as the arc it's formed. So AC is formed by this angle here, which tells you the measure of arc AC is what? 50 degrees. And we do measure of arcs in degrees. CAD goes C, then A, then D. What would that be? 180 degrees. And ACD goes A, C, D. How do I find that?
I thought it was 230.
How do I know that? Good. It's the 180 plus the 50, which is 230. Does that make sense?
Yeah.
Okay. Somebody said no. No. If I want this whole thing, right, and this part of that is 180, then all I have to do is add that 50 onto it to get that whole thing. So notice that we're doing these in degrees. These are going to be in degrees. You're going to learn something about length of an arc. That's different. That's like if I took a string and actually measured the edge and then put it against a ruler. That's length. Measure is determined by the angle that forms it. Adjacent arcs are arcs that have exactly 1 point in common. So they are next to, they cannot overlap. So QR would be adjacent to SR, or QR would be adjacent to QT. Okay, RS would be adjacent to ST, ST would be adjacent to TQ. They can't overlap. They have to share a point. Okay, so they're next to without overlapping. An arc addition postulate. So if you remember way back, we did segment addition postulate, we did angle addition postulate. Now we're doing arc addition postulate, okay? Which is the same concept. If I have a big arc and I break it down into its smaller parts, I add those back together, it gives me the whole. So this says the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So if I wanted to find A, B, C, which is what we already have done, I would add A, B, and B, C, okay? And the reasoning there is the arc addition postulate. So you've already used it. You just didn't know it had a name. Congruent arcs and congruent circles and arcs. So we already talked about congruent circles, right? These are circles with equal radii. Congruent arcs are arcs that have the same measure, and arcs of the same circle or congruent circles.
For the interruption, Sophia Curry reports student services. Sophia Curry, thank you.
Okay, so not exactly equal, but because these are vertical angles, right, and they are both central angles, I would know that these are equal. Let's say this is 60 degrees. That makes this 60 degrees, and that would also make the arcs congruent. AB would be congruent to DC. So we're talking about arcs in the same circle, or if I had another circle, I would need to know that it's congruent. How do I know they're congruent? Good. So if I had something like this, not a very straight line, this, and this said 5, and this said 5. Now these are congruent circles, okay? And if this said 60 degrees, M, N, O, P, now these are also equal to those, okay? So the circles have to be equal, and then if the arcs are also equal, if the angles are also equal, then the arcs are equal, okay? So you can compare two arcs in the same circle or in congruent circles. Without those 5s, if one was 5, had a radio 5, one radio had a 6, even if the arcs are both 60, they are not congruent because the circle itself is not congruent.
What is it? Can they have vertical angles?
Yeah. Yeah, everything we know up to this point applies inside a circle. So you're going to see linear pair, you're going to see vertical angles, all that stuff still applies. All right, this one says, name A, 2 minor arcs, B, 2 major, 2 semicircle, an acute central angle, and 2 congruent arcs. Try it. See what you can get. And O is the center of that. You see how it's bolded? That's an indication that it's the center. Okay, give me an example of a minor arc. AR, which could also be called RA. Those are the same thing. And RC or CR. You could call it either one. Okay. How about a major arc? RCA works. It goes all the way around. RCA. What was the other ones? DAR would still be a semicircle, right? DAR would go like that. That's a semicircle. CRA is also a semicircle. It's still just half. RAC works. RAC. What was the other one? DAC. That works. Yep. No, so arcs will either use 2 or 3. Good question. All right, then 2 semicircles. So we just use 2 as an example, right? ARC,
And CDA.
C, what'd you say? CDA, CDA. Yep. RAD, DCR. All of those work for semicircles. Okay. An acute central angle would be what? AOR or ROA. And 2 congruent arcs.
ARC is converted to CAD.
Good, like any of these, right?
Yeah.
Those are the only ones we know measures of. ARC could be equal to CDA, could be equal to RAD, could be equal to DCR. Any of the semicircles would be equal to each other. Those are the only ones you know measures of. But you only needed 2. Questions on that stuff?
Could you name it as two letters, the arcs?
2 letters, it's just, you got to be careful because usually that's a minor arc. So if you're using the same 2 letters, like give me an example. If you said RA and you really wanted to mean this, you have to include another letter because RA implies the shorter.
Okay.
Does that make sense?
Yeah.
So if you're trying to describe a minor arc, fine. A major arc, usually you use the 3 letters. Okay, this one says give the measure of each angle or arc. So again, I'm gonna let you work on it and then we'll go over it. All right, WX is here. All right, so how do I know the measure of that arc? These 3 form a linear pair, right? Or these 3 form a semicircle, right? So if this is 30 and this is 50, that means this is also 50. What would happen in here? That'd be 100.
Thank you.
You're welcome. Have a good day, guys. How about angle WOT?
50.
Good, we just found it, right? 50 degrees. XYT goes X, then Y, then T. How do I find it? What's true about all 3 of those? Or both of those? That's 180, so I have to?
Plus 30.
Good. 180 plus 30 is?
210.
210. And YOT. Good. It's a straight angle, 180 degrees. Yep.
Why is WOT?
Because this was 50 degrees. So if the arc is 50, the angle is 50. If the angle is 50, the arc's 50. It works both ways.
And what if you increase the size of them?
So right now we're only doing central angles. All of these vertex will be on the center. Eventually we'll learn a couple of different ways. What happens when it's not at the center? Yeah, then we'll learn how to find those too. Yep.